So recently I've been working on my compiler. If you guys have any ideas for Temple OS, here's my list of ideas. So this is a bug. You know when you press, if you say Alt, and then, whoops, oh, have to enable, there, okay. Now if I press and hold Alt, then it gives a list of the keystrokes. That list is generated by sending a message and then waiting for an echo. And this is the code that does that. So if you go to the keyboard handler, if the key description flag is set, then it sets the key description, and this is how that's how that pop-up is generated. So here it generates a scan code, and it sets the key description, and then it acts as though it was printed. And then the keyboard handler notices that it's a probe. Anyway. So to make a long story short, it seems to require a delay. It doesn't work if I just say yield. What file are we in? We're in training. Okay, oops. Training. Where did it go? Here it is. Okay, never mind. So I should just have to say yield. But if I reboot and do this, now if I say Alt, look at it, LMPV. LMPV. I'm looking right here, LMPV. Supposedly, sometimes it drops some. It doesn't do them all. How about the V is underneath the cursor, the mouse cursor? What about Control? Maybe that's it. I don't know. Control Alt. Okay, Control Alt. It's under the mouse cursor. Control Alt. It's not coming up. What's going on? Control Alt. Oh, I exited my. Okay, well, it doesn't appear to be doing it, but in the past, it would forget about. It would drop. Not all the probes would respond. Anyway, puppy. He's not a puppy, actually. He's a dog. Anyway, so, do you have any ideas for Temple OS or what we can do today? Let's get God to talk on what we can do today. Okay, well, Mr. God, nobody's watching. So, there was an attack. Brussels attack. Anyway, 13. It was 12 a little bit earlier. What do you think of that, Mr. God? So people blame God. You think God's talking about this?
Team-nighted chits is about as much fun as a four-letter word for boring. So she went to the Samsung Experience Shop in Best Buy and picked up the new Galaxy S7 Edge, which snaps into the Samsung Gear VR.
What the heck? Oh, there we go. Okay. So let's see what these clowns. These guys are clowns. Link dot device cross compiler. So they have this crazy stuff. In Temple OS, hold on a second. I'm just doing a diff to see if I changed anything. Okay, so if you want let's make this interesting. Okay, so you can put assembly code right in the middle if you feel like it. So we can say move RAX. Haha. Call. Quick charge. So, we say unassembled function. Put chars. There's where it got the haha. So if we want, we can. So what it does is, if a statement starts with a valid opcode, then it's an assembly instruction. You could think of it as beginning of line, although it doesn't have to be beginning of line. Anyway, so you might wonder how I did that. Well, I think they talk about context-free grammars, and mine is the opposite. So, actually, no, context is not really the issue. It's so this parses a statement, and what it does is it right here is where a statement can be in braces, and it calls recursively to parse a statement. Parse statement, there's the recursion. If it's inside of braces, if we get an identifier, it checks if it's a keyword, and it does all the keywords. There's the keywords for Holy See. And if it's not a keyword, then it checks if it's a known symbol in the hash table. If it's a type, then it must be declaring global variables or something. If it's an opcode, then it parses an opcode, an assembly instruction. If it finds a string, here's strings and characters, then it calls makes a function call as though it's a printf. So anyway, I laugh at one of the things that you frequently see is sometimes you see push the flags. I don't know if you want to turn off interrupts, then pop flags. So this is using the system stack. Let's see. Pop flag, push flag. I'm a little bit disappointed that you can't do assembly at the command line. Now it's a little bit more efficient. If you have a lot of code, it compiles a little bit faster. This is an option. You don't have to do it this way. It's a little bit faster for compiling, which is a ridiculous thing to worry about. So see if anybody's watching. So, hi. See if anybody's watching. So let's see what God says. Say hi to the people, Mr. God. I live with my parents. I don't know. Keith is one of my brothers. Okay, so let's go. Sometimes I think about doing a tutorial course for C++, but Holy C, whatever. Anyway, This assumes that you know C already, and then it teaches what's different with this dialect. I could also try and teach assembly language. In the demo directory, there's some assembly language examples. My generation had to learn how to multiply by hand with the 6502. When I was in 8th grade, 1983, when I was in 8th grade, we had to do it this way. 8 bits, shift, logical shift right. What is this? I don't know. Hello, sorry, I don't know what that is. Logical shift right. Branch carry cleared. So this is what we had to do when I was a kid. I don't think that was a 16-bit. I think it was just an 8-bit. Anyway, when I first implemented when I made my first compiler for on my website, in the files history, you can see my first compiler. And the interesting thing is I did interrupts for doing 64-bit math. I don't think this is it. So what I would do is I would call an interrupt. I think it's we can try to uncompress this. Let's copy to, I don't know why I like to put it. Let's put it in temp. Control Alt Tab. This is Linux. Change temp ls TOSZ IRQ and ASM. Does this have? I don't think it was assembly. I think it was software interrupts. Here we go. C out was software interrupts. Where is it? I made it so that all the math operations were done with software interrupts in the compiler to do 64-bit math. Maybe it's a little bit, that was 2005. Surely I have it in here. This is Luzos. Oh, maybe I redefine them? Do you think I set the software interrupts later? Anyway, It might even be in the compiler. What I'm looking for is some software interrupts that did 64-bit math when I was running on a 32-bit machine. Oh well, we can. I don't think this is it. It wasn't assembly. It was C. It was probably called math. Okay, let's. This is, all of these files are on my website if you're interested. Anyway, oh well. Okay. I know it wasn't assembly. It was parameter 1, this could be assembly. Hold on a second. Oh, peak message. Oh well. So maybe you want to do 128-bit math operations. You can do it this way. This is not the fastest to do multiplying. There's a divide. So I thought about, not very seriously, but I could make a tutorial for assembly or a tutorial for Holy C that starts with a beginner. There's so many C tutorials that I feel ridiculous doing yet another C tutorial. Anyway, assembly, my generation learned 16-bit assembly. Perhaps this generation only needs to learn 64-bit. So if I tried to teach, I would try to teach starting with 64-bit. It's really unfortunate how difficult it is to learn with this machine. It's a lot easier if you have a simple 6502. Anyway, a simple 6502. Anyway. Yeah, this is division. I could explain how it works. What it does is, let's say well, anyway, it does trial subtraction, or in other words, comparison. Comparison and subtraction are almost the same thing. Anyway, and If it can subtract, then that means the bit is a 1. If it can't subtract, it means it's a 0. Anyway. So, oh, I love this. I'm proud of, this is the ultimate BuzzFizz. So, my generation understands that division is a slow operation. And so, whenever I hear about somebody using division in BuzzFizz, it kind of makes me laugh. Some people brag about their BuzzFizz solution. I use a counter. I've never seen anybody do BuzzFizz like that. Then there's this really cool thing I have where so I have support for multiple characters in one integer. So if you call put chars, it prints a character, the low two. I'm not doing international Korean, Chinese, and stuff. I do just ASCII. Actually, it's 8-bit ASCII, which is anyway. So I print an 8-bit character, and then I shift over. So the net result is, if you put multiple characters in an integer, then this is a trick I learned at Ticketmaster. I can talk about Ticketmaster tricks. What they did is they had a all devices were 4-digit, and so they used a long word, a 32-bit word, to grab that. The directories were all 8-character, and so it used a quad word to move those around. And then the file names were 8.3.1. So it used a quad word 64-bit to grab those. Then these two it stuck in a long word. So all of the it was one level of directory. It did not have directory within directory. And so for all their disk code, it was really efficient. You know, looking back, I'm not sure how important that was for them. I could talk about their database. There's a demo in TempleOS. What this does is it has a 100-block file that's made. A disk block is 512 bytes, although some newer machines have 2048, I do believe. CD-ROM is 2048 as well, but my file system hides that so that everything is 512. If we write an account number 10, Terry Davis, address Sickle Lane. Okay, so I wrote an account. Let's write another account. 12, internet person. Let's see, I don't know about. Okay, now if I read an account number, so this is the ultimate in speed. The account number is a block number. So this would be even faster than SQL. Anyway, or that should be no surprise. Anyway, but there's no. You would have to do all the locks and B trees on your own. Anyway, let's look at how. So it initializes a calls fopen, and I guess my file routines are not standard. So fopen flags count. So if you open a file, you can. My files do not grow. All the files have to stay the same size. You can make them. Never mind. I think they can grow at this point, but in the future they're not going to grow. With the FAT32 file system, they can grow, but we're going to get rid of that. Anyway, so declare how many blocks, and if you're so one of the tricks is to do a form. I declare a class account, and these $ commands tell the form how to prompt for fields. Anyway, what if I made this a little bit smarter? That might be unwise. You see the 64? What if I made it smart enough to discover that? That's actually not too bad. We could do that as a project. That sounds like a lot of fun. I have to think if this is a scatterbrained idea or not. I want transparency. I don't like voodoo magic. That's one of the whole purposes of this operating system is transparency. But that would. So how could we do that is the question. So not do form. So this takes a you pass it a class, and it finds the metadata that we created for the class. And what does it do? This could take a while to explain. So it finds the metadata called format string, and it builds a document with those document commands. There, it's printing out the format string. And when it does that, it creates a document entry. And what we do is we call format. This gives the initial. Let's say you're prompting and you already have values. This fixes the text of the field. So a form is a document. And if we look in here, so when you declare a C++ or a Holy C class, you can make a metadata item called format string. This can be any identifier you put here will be considered metadata until it finds a semicolon that ends the and then you can call do form. Where is that? Doc form, not, it used to be do form, now it's doc form. So we anyway, so the size of the array is actually available within member list root. I thought we were going through the oh, this is the class member list. So it's going through all the members of the class, and a member list entry has array dimensions. Well, look at that. So array dimensions has a count. And so if we wanted to make a little bit smarter, we could say doc.me. So the document entries have, do you want to play around with this for a second? The document entries have a length, and that is what do you see the length here? What we could do is we could say document entry length equals member list array dimension. What was that? You want to play with this? So where was it? Member list. Dim count. Dim count. Okay. Member list. Dim count. Okay, so what we're going to do, first of all, we are going to raw print 2000, comma, count %d. I think member list string. So what I'm going to do is when you're debugging, a raw print bypasses the window manager, and it prints directly to screen memory. So what I'm going to do is I'm going to print the name of the member and then the count. Okay, so reboot. This only happens when we do a form. So for example, if I say Control F to find text, count 0, replace text, count 0. That's not what I wanted. I wanted to that's the wrong value. What we want I think we want total count. That's not what we want. There, total count. So what would be nice is if the default length was set with this. How can we accomplish that? That would be a very safe way to operate. So in order to do that, okay, let's get rid of that. So we get the making it have a default is not as easy as it sounds. Oh, what if I make a default of -1 as part of okay, let's do that. Are we really gonna do this? Sometimes I get nervous. Let's do it. Okay, so we go to oh, let's reboot. That's so that I don't accidentally do a form. Okay, so we go to the doll docs, plain text. This is where, oops, does God want to talk? So here's what we're gonna do. We're going to go to over here on this side, it's parsing plain text, parse $command. So this is where it parses, and we want to set the length to -1. Oh, it looks like we already set it. Length default. Uh-oh. Oh no, I just changed this in recent years. There's shit. That's actually good. Damn it. How can we... Oh, how about... I know what we can do. No, that's not good. I was gonna reset it if it was smaller than, or if it... Do you have any ideas? You don't even know what I'm talking about. Zero. Uh-oh. Okay. Are we back? My is it a